So we know how to evaluate limits where a function is continuous. We just plug in. Now we need to talk about how to evaluate limits where a function has a hole. And we're actually going to start up the exact same way that we do for where we're continuous. We're just going to plug in. But if a function has a hole, plugging in will give us 0 over 0, which is a problem. Our goal, any place our function has a hole, is to create a new function that is identical to the original one, except it just doesn't have that hole. Our goal, create a new function that is identical except for the hole. So for example, let's say I have a function that looks like this. My goal is to create a formula for a function that looks like this. The exact same thing, just no hole over there. Because if I can create a function that's the same just without a hole, all I have to do is plug in to this new function that's the same, and whatever value I get over here will be the limit that I get as x approaches this hole over there. To do this, we're going to take our function and we're going to simplify it. And I'm going to show you 3 different methods today for simplifying. Well, maybe today. We'll see based on when you're watching these videos. There are 3 different techniques we're going to look at. But step number 1, simplify the function. Then, once we have it simplified, we're just going to plug in to the simplified version. If then we get something in the form some number over some other number that's not 0, whatever we get is our limit. So I'm going to need to do some simplifying, and I'll show you again 3 different methods for dealing with that. Then we'll plug into our simplified version. As long as I don't get a 0 in my denominator, that number I get will be my limit. Our first simplifying method is called factor and cancel. And for our first example, let's take a look at the limit as x approaches 2 of x squared plus 4x minus 12 over x minus 2. Before you do anything, you should try to plug into this function. So I'm going to do that work on the side over here. I'm going to go and plug in my 2. I'm going to get 4 plus 8 minus 12 over 2 minus 2. I'm going to get 0 over 0. Yeah, that's a problem. But getting 0 over 0 is our sign that there's probably a hole. And I need to try to do some simplifying. Well, to simplify this, I'm just going to do exactly what this name suggests. I'm going to do some factoring, and I'm going to do some canceling. This is going to equal the limit as x approaches 2 of, I'm going to factor this thing into x plus 6 times x minus 2 over x minus 2. And what do you know? X minus 2 on the top, x minus 2 on the bottom. We can cancel those things. I'm going to turn this into the limit as x approaches 2 of x plus 6. And the whole point is this function is the same as the original. It just doesn't have that hole at x equals 2. But if you were to graph both of them in the graphing calculator, they would look identical. Well, now I'm just going to go and I'm going to plug in my 2. I'm going to say 2 plus 6, and I'm going to get 8. I'm going to plug in. Plugging in, if it gives me 0 over 0, means I need to do some simplifying. So here, I'm going to do some factoring up top, and then I can cancel the x minus 2's. Then I'm going to plug into that simplified version, and the answer I get will be my limit. One thing that I do need to talk with you guys about is limit notation. And I'm a bit of a stickler with this, as is the College Board on the free response parts of the AP exam. Notice that I continue writing this LIM symbol every single time until I actually go and take the limit by plugging in the 2. So over here I have my original problem. Here I did some simplifying, haven't actually plugged anything in. I'm still going to write that limit as x approaches 2. Here I've done some more simplifying. I crossed out the x minus 2s. I'm still going to write my limit as x approaches 2. But now I'm going to go and take my limit, which means I'm going to plug in a 2 where the x is. I'm going to get 2 plus 6, no limit symbol anymore because I'm taking my limit. I'm plugging in the 2 where the x is. And I'm going to end up with 8. Limits over here, no limits in steps like this. Please make sure, as you continue watching this, you're watching my notation and making sure the notation you're getting in your notes looks the same. Limits when appropriate, no limits when not appropriate. Let's take a look at the limit as x approaches negative 1 of 2x squared minus 3x minus 5 over 2x squared plus 5x plus 3. Actually, why don't you see what you can do with this? I think you can figure out how to do this one. Well, I'm going to first plug in, and I'm going to get 2 times negative 1 squared, that's 2, plus 3 minus 5, 0 on the top, but that's not quite good enough. Negative 1 squared is 1 times 2, minus 5 plus 3. This looks like 0 over 0. Yep, I've got to do some simplifying, because it probably has a hole. Well, I'm going to try to factor and cancel here. Limit as x approaches negative 1 of the top gets factored into 2x minus 5, x plus 1. I hope you got that piece. The bottom gets factored into 2x plus 3, x plus 1. By the way, x plus 1, sure, plugging negative 1 into that on the top and that on the bottom is where the 0 over 0 came from. I'm going to cancel that. And I'm going to keep writing LIM as x approaches negative 1 because I'm not plugging in yet. I'm just rewriting that original function. Now I'll go and actually take that limit. I'll plug negative 1 into that. So 2 times negative 1. Yes, do make sure you show the plugging in work. Top, negative 2 minus 5 is negative 7. Bottom, negative 2 plus 3 is 1. So this limit, negative 7. Let's see what you guys can do with this one. The limit as y approaches 0 of 5y cubed plus 8y squared over 3y to the 4th minus 16y squared. See what you can do. Well, plugging in, first of all, hopefully you realize it doesn't matter that it's y rather than x, just what we're calling the variable. But plugging in gives me 0 plus 0, 0 minus 0, 0 over 0. Okay, so I've got to do some simplifying. Okay, well, this is going to give me the limit. As y approaches 0, I'm hoping that you realized to factor both the top and bottom, all you need to do is take out the GCF, the greatest common factor. Up top, I'll pull out a y squared, and I'm left with 5y plus 8. On the bottom, I will also pull out a y squared. I'm going to get 3y squared minus 16. Those cancel. This gives me the limit as y approaches 0 of 5y plus 8 over 3y squared minus 16. Okay, plug in your 0. We're going to get 0 plus 8 over 0 minus 16. That's 8 over negative 16. That is negative 1/2. Limit as y approaches 0 of this thing is negative 1/2. By the way, one other notation thing, do not write things like the limit as y approaches 0 equals negative 1/2. There needs to be something inside this limit over here. Limit as y approaches 0 by itself means nothing at all. Either just write negative 1/2 for the answer, or you could write the limit as y approaches 0 of that original function equals negative 1/2.